નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Standard 9th, Subject Science, Chapter 11, Work and Energy. Dear students, in the last video we have discussed about the work and scientific conception of the work. Today we will see work done by the constant force. How is work defined in the science? To understand this, we shall first consider the case when the force is acting in the direction of the displacement. For example, if you move the object, so this is the force we applied here. So this displaced here. The object is moved here. So then you will say, okay, this is the B. So this much is displacement or movement. So this is in science. This type of is called as work. So here work is done. So let a constant force F. Suppose consider let a constant force F. Okay, constant force we apply on an object. Let the object be displaced through a distance. Okay, this object distance through a, and here the S in the direction of the force. Okay, this direction S in the direction of the force. So work done, let W is the work done. So work done is equal to F into S. So what the formula you have used? Work done is equal to, we define the work, be equal to the product of the force, equal to the product of the force and as well as displacement. So that's why work done formula is what? W is equal to Fs. So W is equal to Fs. See, work done, normally work is the product of the force and the displacement. So therefore, W is equal to Fs, or you can write F into S. Okay. So now, the work done, for example, okay, here, then you see in your books, it is given on the textbook, on the table, okay, brick is there. Okay, this is the brick, here they have shown the brick. Okay. So when you apply the force on the brick, so here, okay, see that this is the brick. And you apply the force here, this displays up to here. Okay, then, so here, thus work done by a force acting on an object is equal to the magnitude of the force and magnitude of the force multiplied by the distance moved in the direction of the force. Okay, so the work is done or work done by the force acting on an object is equal to the magnitude of the force and magnitude of the distance moved in the direction of the force. So means F into S. So work has only magnitude. Work has only magnitude or value but no direction. Okay. So for example, if force 1N, okay, suppose if you apply force is 1N. Okay, and distance S is equal to 1m. Okay, S is equal to 1m. Okay, 1m, and then the work done by the force will be 1 mm. So 1 mm. Here m is small. Okay, 1 mm. So means, so work done here. Here the unit of work is, see, if you apply the force 1n and the distance moved 1m, then the work done is equal to 1 Newton meter. So dear students, the unit of the force is Newton. You know that unit of force is Newton and that of the displacement is meter. So therefore, the unit of work is Newton meter, or you can say Joule, or here capital J. Okay. So this way we can write. Thus 1 Joule is the amount of work done on an object when force of 1 Newton displaces 1 meter along the line or along the line of the action of the force. So this way, this is called as a 1 Joule. Now dear students, what is the work done when the force on the object is 0? Suppose, okay, you know that the formula is W is equal to F into S. Suppose here it is what is given here. What is the work done when the force of the object is 0? Okay, force is given 0. What it may be? So answer will be 0. You know that in the multiplication, any 0 comes, so that automatically work done is here 0 value will get. And next one, what would be the work done when the displacement of object is 0? Suppose okay, here it may be any number, but here 0 will be there. You know that in the multiplication, any 0 comes. Okay, 0 if it comes, then you can say that. So answer will be, work will be 0. Okay, for both the case. So force or displacement is 0, then the work done will be automatically 0 only. Okay, dear students, here one calculation given in the textbook. A force of 5N is acting on an object. So try to understand. A force of 5N is acting on an object. Okay, try to understand this one. A force of 5N. Okay, see here the object will be there, and this is 5N. Force will be applied here. And then the object is displaced through the 2 meter. Okay, 2 meter. So this S will be 2 meter. Okay. So this is the S. So S will be 2 meter. So object is moved here, and this will be S 2 meter. Then question is asked, if the force acts on the object all through the displacement, then what is the work? Work done is equal to, you know that 5 into 2. 5 multiplied by 2. So 10 Newton meter or 10 joule. Okay. So this way you can write. And in the textbook, one more example is given. A force of 7N acts on an object. The displacement is say 8 meter. Okay, 7 and the displacement is 8 meter. Then what is the answer asked here? Question is asked. Let us take it that the force acts on the object through the displacement. What is the work done here? So what is the work done? 7 8 are 56. Okay, 56 Newton meter or 56 joule. So work formula, you know that F into S. F into S. So now consider another situation in which the force and displacement are in the same direction. Okay, consider one more situation here. Another situation. So what will be there? You will understand, try to understand in this example. See, consider the another situation in which the force and displacement are in the same direction. Okay, force as well as displacement in the same direction. Okay. A baby, for example, a baby is pulling a toy car parallel to the ground. Okay, and here toy car will be there. Parallel to the ground, it is dragging. So then what? In the baby exerted a force in the direction of the displacement of the car. Okay, car is displaced like this. So in this situation, the work done will be equal to the product of the force and displacement. The work done is what? F into S. So that already you learned. In such situation, work done will be taken as positive. Here the answer will be positive result. Why? Because the displacement is, when the force is in the direction of the displacement, then the work done is positive. See, the work done may be positive or it may be a negative. But when the force is in the direction of the displacement, then the work done is positive. Okay, got the idea now? For example, we will consider one more situation. Consider a situation in which the object is moving with a uniform velocity. Uniform means, okay, in here speed and particular direction. Speed is same, particular direction. Along with a particular direction. Now, a retarding force. Okay, retarding force means some obstacles is applied in the opposite direction. Okay, it moves like this. But here, some obstacle will be there. Obstacles comes here. See, look here now. The force is here. Here are some obstacles. So automatically it comes back. So here the opposite direction, that is the angle between the two directions is 180 degrees. The same direction. So means 180 degree only. Straight line only. So then let the object stop after the displacement. In such a situation, the work done by this is, as you see, you know that, see, it moves here, but it moves, comes back. So such cases is retardation. So the work done by the force is F multiplied by negative S. So here the negative result you will get. Okay, you know that the work done by a force may be positive or negative. So when you have to say positive or when you have to say negative, work done is negative when the force acts opposite to the direction of the displacement. See, here displacement is like this, but here opposite comes back. So then you will say the negative result. If the work done is positive when the force is in the direction of the when the force is in the direction of the displacement, then it will be positive. Okay, consider one more example here. Situation: lift an object. Okay, take up the object up. Okay, we have to raise the object up. Okay, object is raised up here, and it moves upwards. The force you exerted is in the direction of the displacement. The force you exerted in the direction of the displacement. Okay, you move like this only. Okay, this is the positive. However, there is force of gravity. The force of gravity, you know that Earth has gravitational power that is acting downwards. So here, which one of the force is doing positive work and which is the negative work? See here, the work is done is negative when the force acts opposite to the direction. Opposite means Earth gravitational force opposite to the direction. So that is the negative. Work done is positive when the force is in the direction of the what you have lifted up. So that is a positive. Okay. For example, now example you see a porter lifts a luggage of 15 kg from the ground. Okay, for example, a porter. Okay, you know that in the railway station and this all porter workers lifting the luggage. So a porter lifts or lifting the luggage of 15 kg. Okay, this is the 15 kg luggage. Okay, lift up, raising upwards to the ground and put it on his head 1.5 meters above the ground. How much? 1.5 meters above the ground. Then calculate the work done by him on the luggage. So what you have to do here, formula what? W is equal to, so you know that W is equal to F into S. But here you see the F is here, force is equal to 15. You know that here one thing you have to remember here, dear students. F is equal to Fg means, so F is equal to, here F means what? Mass multiplied by gravity. So that is why mg and multiplied by S. So mg means here mass is 50, gravitational force 10 meter per second square. Round up the earning, otherwise 9.8 only, but for the sometimes it will be given in the round up 10 meter per second square multiplied by S. S is 1.5 meter. S is 1.5 meter. S will be 1.5 meter. So what is the result you will get? After the multiplication you will get here 225 Newton meter, or you can get, or it will be 225 joules, 225, or you can write that 225 joule. Okay, got the idea now? So because you know that F is equal to mg, mass, and as well as gravity will be there, gravitational force. Okay, the gravitational force you know that 9.8 meter per second square. But here but sometimes we are using the 10, a round number will be there. Okay, so in this way you have to find the calculation. So what is the calculation says? A porter lifts a luggage 15 kg from the ground. Okay, 15 kg from the ground, lifted upwards 1.5 meter above the ground. Above the ground how much? 1.5 meter, and calculate the work done. So you know that mass of the luggage is equal to m is equal to, you will write 15 kg, and displacement will be 1.5 meter. So work done is equal to F into S. Use the formulas, but here F is equal to mg multiplied by S. Mg means mass into gravity. So 15 into 10 and multiplied by 1.5. So our answer will be 225 Newton meter or 225 joule. Okay, got the idea, students? Okay, so we'll discuss in the next video. Energy we'll discuss. Okay, thank you. Bye bye.
Thank you for joining us.